Okay, hello students. We're starting a new topic from your arithmetic progression. Today is arithmetic progression part 4. So here is the new topic, sum of a series. First of all, you need to know what is a sequence and what is a series. Sequence is, let's say you have an AP. I have an arithmetic progression like this. Okay, let it continue up to an infinite number of terms. So if they are separated by commas, you're just arranging the number. Here, look, there is a common difference, 2 difference here. All the difference between the term is 2. So if the terms in the arithmetic progression, if they are separated by commas, then we will call it as a sequence. If I add the terms, okay, if I add first term, second term, third term, if I add all the terms in an arithmetic progression, then we will change the name. We will change the sequence to series. So this is a sequence. What is a series then? Let's write the same numbers. So if you add the numbers, if you add the terms in an arithmetic progression, then we will call it as a series. So we have already learned about how to find out the nth term. If an arithmetic progression is given, then we have also known how to determine the number of terms in that particular arithmetic progression also. We have done some examples already, right? Now it's time to find out the series sum. Okay, how do I find out the sum of this? 1 plus 3 plus 7 plus 9 plus 11. If I continue this up to, let's say, 79. Okay, so if you add the terms one by one, that's also fine. But if the number of terms in the arithmetic progression is very large, it's a tedious task, right? It's going to take you very, very long. So if we if we continue to learn about the arithmetic progression a little bit further, then it is very easy for us to determine how to find out the series sum. Okay, let's see how to find out the series sum. We will try to derive a formula. Here, look. How do, let's say I have A as the first term and D as the common difference for an arithmetic progression. Okay. What's the first term here? First term is A. Let's write the second term. Second term, use the formula for A plus N minus 1D. So second term, we will have A plus 1D. What about the third term? A plus, I have to increase the D with 1. So instead of 1D, we will have twice D here, right? So we have 2D here. Fourth term, A plus 3D. If I continue this further, what was the nth term? Nth term look like this. Okay, now what about the sum of these terms? If you add the terms, if I add A, if I add the first term, second term, third term, fourth term, up to any term, what will it look like? Let me write down here. It will look like this. A plus, that's the first term, second term, third term, fourth term, and then you can continue this up to the nth term. Nth term, since there is a bracket on the n minus 1, we will use a second bracket. Okay, so the thing is, in order to derive this formula, let us represent the sum of the first term, second term, third term, fourth term up to the nth term by a symbol. Okay, you have already known this part. So let me rub this off. No need. So sum of an AP series. How do we write this? We will write this as first term, second term, plus third term, plus fourth term. And we have to continue this until nth term. Okay, like we have done here, we will put this as first term. This is the second term. This is the third term, fourth term here. And then you continue until the nth term with this. Okay, so let us write this portion down here. First term is A, right? Second term is A plus D, A plus 2D. And then we will continue this until nth term is A plus n minus 1D. Let's say after adding all the terms, we obtain a value called Sn. Okay, Sn just means that sum of n terms. So we are writing the sum of n terms from first term, second term, third term, and then we continue it until the nth term. We can write this in the reverse order, right? nth term first. Then after nth term, what comes next? N minus 1th term. And then you continue then. Imagine this like this. I'm writing 1 plus 3 plus 5 plus 7 plus 9 plus 11. Okay, how many terms are there? There are 6 of them. It's writing like this. The sum that we obtain here, it will be the same if I write this in the reverse order also. 11 plus 9 plus 7 plus 5 plus 3 plus 1. The two value will remain the same, right? So I'm writing this sum in the reverse order like this. We will still get the same value of the sum. So we will write from the reverse order. We will have a plus n minus 1. This is the nth term. Before nth term, what term is there? You have to replace the n minus 1 with l minus 2. Next is a plus, you have to replace the n minus 2 with n minus 3. And then you continue, and then at last we will have the third term, the second term, and then the first term. Okay, let this be the equation 1. Let this be the equation 2. So this is equation 1, this is equation 2. If I add equation 1 and 2, what will we obtain on the right hand side? Let's see. First term and the last term will be added. Second term and the second last term will be added. Third term and last third term will be added. And then we will continue so on, and then we will repeat adding last term with the first term again. So here, if I add these two equation 1 and 2 on the left hand side, Sn plus Sn is how much? Twice Sn, right? So we will write here adding equation 1 and 2. What has happened to the left hand side? We will have Sn plus Sn. Okay, now come to the right hand side. We have to add this and this. You get it? Okay, let me surround them with a red marker. Add these two. What do we have? First we have a. Next we have a plus n minus 1 d. If I open the second bracket here, what we are left with is a plus n minus 1 d. The two are the like terms here, a and a. So we will have twice a plus n minus 1 d. So when I add these two surrounded, these two marked portions, what we get on the left hand side, on the right hand side, I'm sorry, it will be twice a plus n minus 1 d. Let me enclose them inside third brackets plus. How did we obtain this? We obtain this by adding first term and last term. Now let's add the second term here and the second last term, last second term. So I'm rubbing this off here. What are we adding now? We are adding second term and the second last term. Okay, now look, if you add these two, what do we get? Okay, let's check. We get something like this. A plus d plus a plus n minus 2 d. Since there is a plus sign in front of the second bracket, no need to put the bracket in there. So I'm just opening this like this. Okay, now look, these two, how much is it? A plus a, twice a, right? Twice a plus. What about these two? D and D can be taken as common factor. What is remaining here? 1 is remaining here. So we will have 1 plus n minus 2. D is taken as common factor. These two are added. We have obtained twice a. This and these are added. We have taken D as the common factor. From here, 1 is left out. From here, n minus 2 is left out. Look, 1 plus n minus 2. 1 and 2, we can subtract them. 1 minus 2 is how much? It's minus 1. So I can replace the 1 plus n minus 2 as n minus 1, right? Okay, so I'm just rubbing it off and then I'm replacing it with n minus 1. So we get n minus 1 d. So when we add the second term and second last term, we again obtain twice a plus n minus 1 d. Same result as adding first term and the last term, right? Okay, now let's rub this off. When we add the second term and second last term, we obtain twice a plus n minus 1 d. If I add this third term here and the third last term, okay, we will be able to replicate the same value. We will still obtain twice a plus n minus 1 d. Plus you will continue to obtain twice a plus n minus 1 d until when you add this is the last term in the equation 1 and a here. If you add these two again, It's the same value is adding this and this, right? What did we obtain? We obtained twice a plus n minus 1d. So whatever term that you add, when you write the uh, terms of an AP in the proper order and then you write in the reverse order, when you add the terms, whatever value that you are obtaining, it is always twice a plus n minus 1d. One more hint. If I add 2 plus 2 plus 2 plus 2, how many 2's are being added here? 4. So I can write it as 4 into 2. If I add 3, 4, 5 times, let's say. So I can replace this as 5 multiplied with 3. Here, like writing 3 plus 3 plus 3 plus 3 added many times. If there were n number of threes, okay, instead of writing 10 threes or 4 threes, let's say there are n number of threes. So we will write this as n into 3. Same idea, you do it here. What is being added here? Twice a plus n minus 1d. How many twice a plus n minus 1d are there? There is 1, there is 2, and then there is another third one, fourth one, fifth one, and then we write until which one? This one is the nth. How many n's, how many terms are there? First, second, third, four, five, six. You continue until which one? Nth. So I can replace this whole by writing like this. Twice a plus n minus 1d. It is being added how many times? It is being added n times. So I will just multiply an n here. Okay, take care of the left hand side also, Sn plus Sn. Since these two are the same value, we will just write twice Sn. What did we want? We wanted to find out the sum of the terms of an arithmetic progression. We have an AP, we have the first term, we have the common difference. So we express the first term, second term, third term like this. So what we wanted was, we wanted to know if we add all of this, what will be the result? Yeah, the result is what? Sn. So our goal is to find Sn. Okay, so I'm keeping this last line. I'm rubbing all of this off. Okay. So here, let's rub off the last second line also. What we are obtaining here is twice Sn is equal to n whole bracket twice a plus n minus 1 whole bracket d. If I wanted Sn, the 2 will go to the other side. So let's go like this. Twice a plus n minus 1 d. Okay, let's put this as equation number 3. I can separate the bracketed portion like this. Look, n by 2. Instead of writing twice a, I can write a plus a, right? Keep the n minus 1d intact. Look, what is this portion? What do you remember? You remember that this is the formula for the nth term, right? In this case, what was the nth term? Nth term was the last term. What is a? A is the first term. This portion is the last term. Okay, this portion is the formula for the nth term, but in this case, for a given AP, the nth term is the last term. So I'm putting the underlined part as the last term, which should be represented by L. So we will just write n by 2, a plus L. What is L? L is equal to a plus n minus 1d. What is L? Is the last term. Okay, now we have two formulas. One is given by equation number 3 right here. Another is given by equation number 4 right here. So when you are given an arithmetic progression, you can do two things. If the last term is given, you will use this formula, but you need to know what is the value of n. What is n? N is the number of terms. What is a? Is the first term. L is what? L is the last term. Or you can use this one. If the last term is not known and then you are just given the number of terms, the first term and then the common difference. If those are given, then you can use this formula. If the last term is given, you can use this formula. But of course, the building blocks of how to find out the sum of an arithmetic progression is you just have to know A, that's the first term, D, that's the common difference, and N. What is N? N is the number of terms. Okay, let's take up a few examples in order to illustrate how this formula works. Okay, Let's take up an example from your textbook. So question number 1 from your exercise 6.2. This is exercise 6.2. Okay. So question number 1, Roman number 1, it's an arithmetic progression is given here. Question 1's what? Question 1's sum. Sum of all these terms. Up to how many terms? Up to 12 terms. Okay, so let's write Roman number 1 solution. Sn will be what? Sn is the sum of n terms. How many terms are there? There are 12 of them. So this n will be replaced by what? 12. So don't write n here. I'm writing 12. S12 is equal to, you have to add 3 plus 8 plus 13 plus 18 plus. Up to how many terms? Up to 12 terms. So here you can use which formula you have to know properly. Sn is, there are two of them. Either it's a plus l if the last term is not, or you can use n by 2 twice a plus n minus 1d. Here the last term is not given, right? In this arithmetic progression, last term is not given. Here, where is the last term? It's not given. We will take up another question in the next question when the last term is given. But we can find out a is here. D, you have to subtract 8 and 3 or 13 and 8. And then how many number of terms are there? There are 12. Okay, so in order to find out the sum of 12 terms, we need to know three things. Obviously, we have to use this formula right here. We have to know N, A, and D. Are all of those available from this itself? Yes, we do. We have A here. We can find out D. And N is how much? 12. So let's write here. A is equal to 3. D, you subtract 8 and 3, we get 5. How much is N? The number of terms is 12. Okay, now find out the S12. S12 means the sum of two 12 terms. You know the meaning of the sum of the 12 terms, right? This is first term, second term, third term, fourth term. I can write 23 next, 28 next, fifth term, sixth term. You continue this until you reach how much? You reach 12. Not the 12th number, but the 12th number, the 12th. Okay, now let's find out the S12. Very easy. Just put in the value of N, A, and D in this formula itself. So we will write 12 by 2 twice A. A is how much? 3 plus N is 12 minus 1. D. D is, we have already found out to be 5. Okay, let's match with the formula. N by 2, I'm writing 12 by 2 because N is 12. Twice A, we have 2 into 3 because A is 3. N minus 1, we are writing 12 minus 1 because N is 12 again. D is how much? D is 5. So 12 by 2, you can cancel it out. 12 by 2 is 6. Inside the third bracket, what do we obtain? 2 into 3 is 6 plus 12 minus 1 is 11 into 5. 6 bracketed portion is 6 plus 55. We have 6 into 61. How much is it? 6 ones are 6. 6 6 are 36. So if you add up to the 12 terms, the result that we are going to obtain as per the formula for the sum of n terms is how much? It's 366. Okay, let's do one more question. Roman number 4. Roman number 4 is different in the sense that the numbers, the next number is decreasing. If the next number is decreasing than the previous one, you should know that the common difference is a negative value. Because you are adding a negative value, that's why the numbers keep decreasing. Okay, not that. Okay, now let's come to Roman number 4. How many terms, up to how many terms do we want this series to be added? We want to add up to how much? Up to the 14th term. Okay, so here we will just write is 14 because we wanted the sum to be up to 14 terms. We will write 4.5 plus 4.3 plus 4.1 plus 3.9. We don't know the last term, so we will just replace it by dot dot dot. That's indicating continuance. What is A here? A is 4.5. What about D? You subtract this and this. Don't subtract the smaller from the bigger, okay? You have to subtract this from this, as you remember from the first and second class. So we will subtract 4.5 from 4.3. Sorry. So this is minus 0.2. Now how much is n? The number of times that we have to add, it's given as 14. Again, since the last term is not known, we will not use this form. We will use this one. So use the formula. S14 is equal to n by 2 is 14 by 2. 2 into a is 4.5. N minus 1 is 14 minus 1. D is how much? Minus 0.2. Let's work it out. 14 by 2 is 7. Bracket. 2 into 4.5 is 9. 14 minus 1 is 13 into minus 0.2. Okay, I can remove the minus sign. You can do one more step here. Plus and minus, if you multiply, we are going to obtain minus sign. So just replace the plus sign here with a minus. Okay, that way I can lose the minus sign here. So let's do it. Minus 13 into 0.2. So 7 into 9 minus 13 into 0.2. How much is it? 13 to the 26. So we get 2.6. How much is the result now? 7 into 9 minus 2.6. We get 6.4. So this is 6 4s are 24. 7 4s are, I'm sorry, 7 4s is 28. 7 6 are 42. So 44.8. So if you continue adding this and this, how much is it? 8.8. Continue 8.8 and 4.1 is 12.9. Continue 4.9 into 4.9 with added with 12.9, it will be how much? 14 point, I'm sorry, it will be 8, 15, 16.8. If you continue adding up to the 14th term, then we will have 44.8 as the result. Okay, practically, let's say you are asked to add from 1 to 100. So how to find it by using this formula right there? Let's say you want to show off. If you want to add 1, 2, 3, 4, 5 up to, let's say up to 100. Simple. You can either use this formula or this formula. It's up to you. How many number of terms are there? There are 100 of them because you are counting from 1 until 100. So here in this case, n is how much? N is 100. How much is the common difference? Look, 1, 1, 1. Common difference is 3 minus 2 or 4 minus 3. There will be 1. And then first term is also 1. In this case, the last term is known, right? Since the last term is known, the L is how much? 100. It's easier to use this formula because there are less number of multiplications and additions. So you just use this term. If I add from 1 until 100, the result will be, you put these values right here. And by 2, we will have 100 by 2. 1 plus L is 100. So 50 into 101, 5050. If you want to add from 1 to 10 also, you can use the same formula. So in case of 1 to 10, we will have, if you add from 1 until 10, if you add 1, 2, 3, 4, 5, 6, if you continue adding until 10, what we are going to obtain is in here n by 2, we will have 10 by 2 into a plus L will be first term is 1, last term is 10. 10 by 2 into 11. So 5 into 11, we will obtain 55. You can check it. 1 plus 2 is 3, 3 plus 4, 3 plus 3 is 6, 6 plus 4 is 10. Continue adding up to 10, you will surely get 55 as the correct answer. Okay. Okay, now let us take up some examples in which the last term is given. This is from your exercise 6.1 question number 2. I'm taking up Roman number 2 and Roman number 4. Look, here last term is given. Okay, so let's use the formula with the last term. The formula with the last term look like this, right? We need the number of terms, we need the A, we need the L. Common difference is not necessary if the last term is not. One problem, in the previous question, it was given how many terms should we add, up to where should we add. In the Roman number 1, you are asked to add up to 12 term. In the next one, you are asked to add up to the 14th term. In here, you don't know how many terms are there. Okay, you have the first term, second term, third term. You continue and then you add up to 182. What term is 182? We don't know. In that case, you have to find out the value of n. That is the number of terms. In the previous question, we have already in the previous video, we have already learned how to find out the number of terms in a given arithmetic progression, right? How did we do it? We put this as the nth term, which was equal to a plus n minus 1d. If a is known and d is known, then you can easily find out the value of n. So let's take up Roman number 2. Roman number 2 Sn is 2 plus 5 plus 8 plus up to 182. Here A is known, A is 2, D is known, D is 5 minus 2, so we get 3. But N, we don't know. In order to find out N, you have to take the 182 here as the nth term. Let 182 be the nth term. What is the nth term now? Nth term is 182. Nth term will be replaced by the formula A plus N minus 1D. Let's put in the values. 2 plus N minus 1. D is 3, 182. So n minus 1 whole bracket 3. If you take 2 to the other side, 192 and 2 will subtract. This and this will subtract. So we will get 180. N minus 1 is how much? 180 by 3, which is 60. And then if you want to find out the value of n here, you have to take the minus 1 to the other side, which becomes plus 1. N is equal to 60 plus 1. So we will get 61. Okay. The only difference with the previous question is that you don't know n. You have to find out the value of n. Okay. So if this is the first term, second term, third term, this is what term? 61st term. If I continue to count from here, if I continue to count until 182, there are how many of them? There are 61. So this Sn will be replaced by what? S61. Okay, let's find out S61. S61 is equal to, we can use the formula here. Since the last term is known, you don't need to use the twice A plus N minus 1D. So we will have 61 by 2. A is how much? A is 2 plus L is how much? 182. So we get 61 into 61 by 2 into 182 plus 2 is 184. 2 nines are 18, 2 twos are 4. So the result is now 61 into 92. Okay, let's multiply. 92 multiply with 61. 92 here. 6 twos are 12. 6 nines are 54. So the result that we are obtaining is 5612. Okay. Okay, so I believe you can do this question by yourself. There is 1, 3, 4 remaining also. You can do the question by yourself, I think, because here in the case of Roman number 4 also, first term is given. This is the A. You can find out the D, right? 5 by 3 and 2, you subtract them. 5 by 3 minus 2, 2 is divided by 1, right? So multiply and cross. 5 ones are 5 minus 6. We get minus 1 by 3. So A is 2, 5 by 3 minus 2 is how much? We get minus 1 by 3, which is the D. Once you know A and D, you will just put minus 6 as the nth term. You find out N and then use this formula. Okay. Very easy. You try this out. We will continue with some word problems from your exercise 6.2. From tomorrow, we will start with question number 3. 4 is a similar one. And then some more questions that will be asked in your board examination that is already previously asked, very important ones. With that, let's finish for today. I will see you all on the next video. Goodbye.